On the morning of February 27th, 2026, something happened to the most distant machine humanity has ever built that nobody on the ground was expecting. Voyager 1 was doing something it has done thousands of times before, a routine roll maneuver, a small rotation. Engineers have commanded for decades without incident, and in the middle of that ordinary motion, its power levels dropped in a way nobody had planned for. For a moment, the team at NASA's Jet Propulsion Laboratory did not know why. And here is the part that should stop you. This is a spacecraft so old, so far away, and so fragile that an unexplained drop in power is not an inconvenience. It is an emergency that could trigger the spacecraft's undervoltage fault protection system, a safeguard that would shut down components on its own and require a lengthy, risky recovery by the flight team. Think about what that means. A machine built in the 1970s, sitting more than 25 billion kilometers from Earth, almost put itself into an emergency shutdown over a power fluctuation nobody could immediately explain. And the engineers had one option: not fix it, not investigate it at leisure. Act first, understand later. That single moment in February is where this story really begins. But to understand why it matters, you have to understand exactly what is out there right now, still transmitting, still alive, still further from home than anything else we have ever made. Voyager 1 launched in 1977. It was never supposed to still be talking to us in 2026. Its mission was a tour: Jupiter, Saturn, a few years of photographs and data, and then silence. The way every other spacecraft before it had gone silent. Instead, it kept it going. It crossed the orbit of Neptune. It kept going. It left the region dominated by the sun's magnetic bubble entirely, becoming the first spacecraft to leave the heliosphere in August 2012, and it kept going. Today, it is somewhere past 16 billion miles from Earth, moving through a region of space no human-made object had ever measured before it got there. And every single day it survives out there, it becomes more improbable. Read that again. Every day it survives is an anomaly compared to what its designers ever expected. Voyager 1 was engineered for 5 years of useful science. It has been operating for nearly 50. But here's where it gets worse. Distance, at this scale, does not just mean far away. It means something closer to isolation than most people can really picture. A radio signal traveling at the literal speed of light, the fastest anything can move in this universe, takes over 23 hours just to reach the spacecraft. And then whatever Voyager 1 sends back takes another 23 hours to return. So when engineers on Earth have a question, any question, a single query about the health of the spacecraft, the answer does not arrive in seconds or minutes. It arrives the day after tomorrow. According to NASA's own mission team, if you send a message to Voyager 1 on a Monday morning, you are not getting a reply until Wednesday, at approximately the same hour, 2 full days later. And this is not a temporary inconvenience that will improve. It is getting worse, permanently, because the spacecraft is still moving away from us at roughly 38,000 miles per hour, and it will never stop, and it will never turn around. By November of 2026, Voyager 1 will cross a threshold nothing human-made has ever crossed before. A radio signal traveling between it and Earth will take a full 24 hours, one entire day, to make the trip. Engineers on the ground will say good morning to a piece of 1970s hardware, and it will not hear them until nightfall. And that is only the distance. That is not even the real crisis. The real crisis is power. And this is where most people watching this story completely misunderstand what is actually happening out there. Voyager 1 does not run on solar panels. Out where it is, the sun is little more than a bright star, far too weak to power anything. Instead, it runs on a radioisotope thermoelectric generator, a device that converts the heat produced by decaying plutonium into usable electricity. It is, in effect, running on its own slow radioactive heartbeat. And that heartbeat is fading. Every single year, without exception, without any way to stop it, Voyager 1 loses about 4 watts of power. 4 watts, less than a household light bulb. But out there, 4 watts a year, compounded across nearly 5 decades, is the difference between a functioning interstellar explorer and a dead hunk of metal drifting through the dark. Forever. According to CNN's reporting on the mission, the spacecraft launched with 11 scientific instruments, and today only 4 still function. 7 have already been sacrificed, deliberately, one by one, switched off by engineers who had to choose, years in advance, exactly which pieces of this machine's mind and senses would go dark first, and in what order, just to keep the rest of it breathing a little longer. And this is where everything changes, because this is not a slow, peaceful decline. This is an active, ongoing battle being fought right now in 2026 by a team of engineers. Most people watching this video have never heard of. On that same February morning when the power unexpectedly dropped, the team knew they were out of room to improvise. So they made a decision that tells you everything about how serious this has become. They chose to kill one of the spacecraft's remaining senses on purpose, before the spacecraft could be forced into an emergency shutdown that might have killed far more. On April 17, 2026, NASA sent the command. 23 hours later, it reached Voyager 1 and the Low-Energy Charged Particles Experiment, an instrument that had been running almost without interruption since the spacecraft launched in 1977. Nearly 49 years of continuous operation went dark. Forever, or at least for now. According to the mission manager overseeing this decision, shutting down a working science instrument was not something anyone on the team wanted to do, but it was described as simply the best option left available to them. Read that again. The best option. Not a good option. The best of the options that remained on a spacecraft, where every remaining choice is now a trade-off between two different kinds of loss. What most people are not seeing is how deliberate all of this actually is. This is not chaos. This is strategy. Years before that instrument was ever switched off, the Voyager science and engineering teams sat down and mapped out, in advance, the exact order in which every single subsystem on this spacecraft would eventually be sacrificed. Of the 10 identical sets of instruments each spacecraft originally carried, 7 have already been shut down. Nothing about this is being decided in a panic. It is being decided the way a general plans a retreat, choosing exactly which ground to give up first, and which ground must be held no matter the cost. And what they chose to hold for now are 2 instruments. One listens to plasma waves rippling through the emptiness between stars. The other measures magnetic fields in a region of space where no magnetic field has ever been measured by any other human instrument. Those 2 instruments, according to the team, are still working great, sending back data from a region of space no other human-made craft has ever explored. Everything else has been given up to protect those 2 remaining senses. Think about what that trade actually represents. An entire spacecraft, its power, its heat, its remaining life, is now being organized around the survival of 2 sensors, listening to whispers at the edge of known space. But here is where it gets worse again, because power is not the only enemy in this story, and it is not even the strangest one. Go back further, to November 14th, 2023. On that day, something happened to Voyager 1 that had never happened in its entire operational history. It did not go silent. Silence would almost have been easier to understand. Instead, it started talking nonsense. It kept sending back a meaningless, repeating pattern instead of usable data. And it did not stop. The carrier signal was there. Engineers knew the spacecraft was alive, that its antenna was still pointed at Earth, that something was still trying to communicate, but whatever it was sending made no sense at all. For 5 months, not 5 hours, not 5 days, 5 months. Engineers at NASA had a spacecraft, humanity's furthest outpost, speaking in a language nobody could decode, and they had no idea why. This is the real story most people never hear in full, because it does not fit into a headline. According to engineers involved in the investigation, diagnosing a problem across this kind of distance is agonizingly slow work by its very nature. Every single command sent to the spacecraft takes about 22.5 hours just to arrive, and any response takes another 22.5 hours to come back, meaning every single question put to Voyager 1. 1 carries with it a weight of nearly 2 full days before there's any answer at all. Imagine trying to fix a machine when every test you run, every question you ask it, costs you 2 entire days just to find out if you asked the right one. There is no room for trial and error in the way we normally understand it. There is only patience and educated guessing and waiting. Finally, in March of 2024, 4 months into the mystery, engineers sent a specific command asking the spacecraft's onboard computer to send back a complete readout of its own memory, hoping that whatever was broken would somehow reveal itself in the data. 22.5 hours later, the readout arrived, and it did reveal something. About 3% of the memory inside Voyager 1's flight data subsystem, the very computer responsible for packaging all of its scientific and engineering data before transmission, had become corrupted. The cause traced back to a single failed chip, a tiny piece of nearly 50-year-old hardware, sitting more than 24 billion kilometers from the nearest engineer who understood it. And here is the detail that should genuinely unsettle you. According to engineers who worked the case, they still do not know for certain what killed that chip. Their best guesses are that it was either struck by an energetic particle from deep space, or that it simply wore out after operating continuously for 46 years. Either explanation means the same thing. Somewhere out past the edge of the solar system, in an environment no engineer designed this hardware to survive this long inside, pieces of it are simply starting to fail, one at a time, for reasons that cannot always be fully confirmed. And this is where the story stops being about a broken machine and starts being about something closer to a miracle. The chip could not be repaired. Nobody was ever going to fly out and replace it. So the team did something almost unbelievable. They took the piece of software that used to live inside that dead memory, split it into smaller sections, found scattered pockets of working memory elsewhere inside the computer, and rewrote the internal instructions, so all those relocated fragments could still find each other and function as one program again. According to one of the mission's own scientists, much of this work involved digging through old paper memos from the 1970s and 1980s, because many of the engineers who originally understood this hardware have since retired or passed away, and rebuilding that knowledge felt, in her own words, like an archaeological dig. On April 18th, 2024, they transmitted the first piece of the fix. 22 and a half hours later, it reached the spacecraft. 2 days after that, on April 20th, Voyager 1 sent back its first readable engineering data in 5 months. This is not chaos. This is strategy, executed by a small group of people solving a problem across a gap of time and distance that should, by any reasonable measure, have made it unsolvable. But suppose, for a moment, that this had failed. Suppose the fix hadn't worked and the gibberish had simply continued. What most people are not seeing is that there would have been no second team to call, no backup spacecraft to send, no realistic way to ever get that data back once it stopped. And that fragility is exactly what makes 2026 so much more dangerous than 2024. Because in 2024, at least the power was stable. In 2026, the power itself is failing at the same time everything else is aging. The team is no longer fixing one crisis at a time. They are managing a spacecraft where the power to run any fix at all is disappearing every single year on a fixed and unforgiving schedule that no amount of clever engineering can pause. So now, here is the plan. The team is currently gambling on, right now, in real time, to buy this mission more years. It is nicknamed quite deliberately the Big Bang. The idea is to perform one large coordinated swap across the spacecraft, turning off some higher power devices while switching on lower power alternatives all at once, rather than bleeding power away instrument by instrument indefinitely. It is a bigger, riskier maneuver than anything they have attempted in the shutdown sequence so far, and because of that risk, the team is not testing it on Voyager 1 first. They are testing it on Voyager 2 first, since it has slightly more spare power and sits closer to Earth, making it the safer subject for a first attempt, with tests planned across May and June of 2026. Only if that test succeeds will they attempt the same maneuver on Voyager 1, and according to the current timeline, that attempt will not happen before July of 2026 at the very earliest. Here's the part that should make you lean in. If the Big Bang works, engineers believe there is a real chance they could bring the low-energy charged particles instrument, the one deliberately sacrificed back in April, back online. Voyager 1 could, in theory, get one of its senses back, but if it doesn't work, the spacecraft loses one of its safest remaining paths to extending its own life on a schedule where every failed attempt costs power it will never get back. And underneath all of this, underneath the power crisis and the memory failure and the Big Bang gamble, there is a mystery that has nothing to do with aging hardware at all, and everything to do with the nature of space itself, a mystery scientists have still not fully solved. When Voyager 1 finally broke through the edge of the sun's influence in 2012, into the region between the stars, its instruments detected something that did not match what models had predicted. The density of charged particles out there jumped so sharply, so far, beyond what any model of the boundary had anticipated, that scientists said the density itself was the strongest proof that Voyager 1 had truly crossed over into interstellar space. That, on its own, was already a strange and beautiful discovery. But it did not stop there. Years later, a researcher going back through Voyager 1's older data found something that nobody had noticed before, a faint, almost imperceptible signal buried underneath the spacecraft's more obvious readings. It was a nearly continuous single-tone hum, a weak but persistent plasma wave emission that had apparently been present in the data since 2017, quietly tracking the changing density of interstellar space in a way no instrument had managed to capture before. On the surface, that sounds like a technical curiosity. It is not. According to independent analysis of that discovery, this persistent signal is described as a genuine double mystery. Its very existence suggests that something out there is continuously pumping wave energy into the interstellar medium itself, and scientists do not know what that source is, or fully understand the mechanism producing the signal in the first place. Sit with that for a second. Nearly 50 years after launch, using an instrument never designed to detect anything like this, Voyager 1 stumbled onto a phenomenon in the space between stars that professional astrophysicists today, in 2026, still cannot completely explain. And it does not end there either. Separate measurements from both Voyager spacecraft revealed that the plasma just outside our solar system's protective bubble is not only denser than expected, it appears to be under some kind of pressure, compressed in ways the standard models never predicted. One proposed explanation involves interstellar magnetic field lines becoming stronger as they drape over the boundary of the heliosphere, potentially triggering an instability that thins out the plasma in that specific region. Another theory suggests interstellar material itself slows down as it piles up against our solar system's edge, creating something like a traffic jam of matter at the border between our home and everything else. Both explanations remain, to this day, competing theories rather than confirmed fact. As one report on the phenomenon put it plainly, describing exactly why this still matters, no one is sure why. So think about the full shape of what is actually happening right now in 2026 at the same moment. A spacecraft built in the 1970s is fighting a losing battle against its own fading power source, 4 watts at a time, forever. Engineers are attempting one of the riskiest coordinated maneuvers in the mission's history, testing it first on its twin, hoping it can buy a few more years, maybe even resurrect an instrument that has already been sacrificed once. And meanwhile, the very last functioning senses this spacecraft has left, the ones the team is protecting above everything else, are listening to a genuine unsolved mystery drifting through interstellar space. A signal whose source nobody can yet name. According to the mission's own long-term projections, even in the best-case scenario, even if the Big Bang succeeds exactly as hoped, Voyager 1 is expected to keep functioning only into the early 2030s, before its power finally drops below the minimum threshold needed to run any instrument at all. And here is the detail that should stay with you long after this ends. When that day finally comes, the spacecraft will not stop moving. It will simply keep traveling outward at roughly 38,000 miles per hour for an effectively unbounded stretch of time, carrying with it the golden record. A gold-plated copper disc holding greetings recorded in 55 languages, music drawn from across human history, and a diagram marking the location of Earth relative to a set of distant pulsars. It will drift on, silent, unpowered, carrying a message from a civilization that may not even resemble what humanity becomes by the time, if ever, anything encounters it. So ask yourself the question nobody has fully answered yet. What happens to the unsolved mystery in that plasma wave data if Voyager 1 goes silent before we understand what is generating it? Does the Big Bang actually work when they attempt it on Voyager 1 itself, no sooner than July of this year? Or does the riskiest maneuver in the mission's history become the moment the story finally turns against the engineers who have kept this machine alive for 5 decades? And when the last watt of power finally runs out, whenever that day comes, is that truly the end of the story, or only the end of the part we are able to listen to?